Welcome to this lesson on angles and shapes and parallel lines. Building on what we learned about basic angle relationships, we will now explore how angles work inside triangles and quadrilaterals, and what happens when a line crosses two parallel lines. These are high-value LANTITE topics. By the end of this lesson, you will know that the angles in any triangle always add to 180 degrees. The angles in any quadrilateral always add to 360 degrees, and you will be able to identify and use alternate, corresponding, and co-interior angles formed when a transversal crosses parallel lines. The most important rule for triangles is that the three interior angles always add up to 180 degrees. This is true for every type of triangle, whether it is acute, right-angled, obtuse, equilateral, isosceles, or scalene. If you know two angles, you can always find the third by subtracting their sum from 180. A triangular garden bed has angles of 47 degrees and 68 degrees. Using the triangle angle sum rule, 47 plus 68 equals 115. Subtract from 180. 180 minus 115 equals 65 degrees. The third angle is 65 degrees. Always check. 47 plus 68 plus 65 equals 180. Correct. An isosceles triangle has one angle of 110 degrees. An isosceles triangle has two equal base angles. Since 110 degrees is greater than 90, it must be the unique angle. If both base angles were 110, the total would be 220, which exceeds 180. So 110 plus 2 times x equals 180. 2x equals 70, so x equals 35 degrees. The two base angles are each 35 degrees. Check. 110 plus 35 equals 180. The four interior angles of any quadrilateral add up to 360 degrees. Why? Because you can split any quadrilateral into two triangles by drawing a diagonal. Each triangle has angles summing to 180 degrees, so the total is 2 times 180, which equals 360 degrees. This works for rectangles, parallelograms, trapeziums, and irregular quadrilaterals alike. A school playground is shaped as a quadrilateral with three angles at 85, 110, and 72 degrees. The four angles must sum to 360 degrees. Add the known angles. 85 plus 110 plus 72 equals 267. Subtract from 360. 360 minus 267 equals 93 degrees. The fourth angle is 93 degrees. Check. 85 plus 110 plus 72 plus 93 equals 360. Correct. When a transversal crosses two parallel lines, it creates three types of special angle pairs. Corresponding angles are in the same position at each intersection. They look like an F shape and are equal. Alternate angles are on opposite sides of the transversal between the parallel lines. They form a Z shape and are equal. Co-interior angles, also called same-side interior or allied angles, are on the same side of the transversal between the parallel lines. They form a C or U shape and add up to 180 degrees. Two parallel fence lines are crossed by a pathway, and one angle is 65 degrees. The corresponding angle is in the same position at the other intersection, also 65 degrees. The alternate angle is on the opposite side between the parallels, also 65 degrees. The co-interior angle is on the same side between the parallels, and since co-interior angles sum to 180, it is 180 minus 65, which equals 115 degrees. Here's a LANTITE-style problem combining parallel lines and triangles. Two parallel lines, PQ and RS, are crossed by a transversal, forming a 72-degree angle with PQ. A triangle between the parallels has a third angle of 48 degrees. First, using alternate angles, the angle inside the triangle at the bottom is also 72 degrees. Then using the triangle angle sum, 72 plus 48 plus x equals 180. So x equals 180 minus 120, which is 60 degrees. This problem combines two rules alternate angles and the triangle angle sum, which is a common LANTITE pattern. Common mistakes to avoid. First, the quadrilateral angle sum is 360 degrees, not 180, a common mix-up of triangles. Second, do not confuse alternate and corresponding angles. Think F for corresponding, Z for alternate. Third, co-interior angles are supplementary. They add to 180 degrees. They are not equal. And fourth, only use parallel line angle rules when the lines are actually parallel. Look for the arrow markers on the diagram. Now try these 6 problems. Problem 1. A triangle has angles of 54 degrees and 78 degrees. Find third angle. Problem 2. An equilateral triangle. What is each angle? Problem 3. A quadrilateral has angles of 90, 115, and 80 degrees. Find the fourth. Problem 4. Parallel lines are cut by a transversal. One angle is 58 degrees. What is the corresponding angle? Problem 5. Using the same setup, what is the co-interior angle? Problem 6. A triangle between two parallel lines has angles of 40 degrees and 75 degrees. Find the third angle. Check your answers on screen. Let's recap. Triangle angles sum to 180 degrees. Quadrilateral angles sum to 360 degrees. Isosceles triangles have two equal base angles. When a transversal crosses parallel lines, corresponding angles are equal. Think F shape. Alternate angles are equal. Think C shape. Co-interior angles sum to 180 degrees. Think C shape. Always check for parallel line markers before using these rules. These angle relationships are essential tools for the LANTITE.